At this point, we're going to continue our discussion of quadratics, and we're going to talk in this video about the most basic transformations of quadratics, and those transformations are translations. We're going to look at both horizontal and vertical translations of the quadratic function. And to do that, we're going to begin with our parent function that we've already discussed. F of x is equal to x squared. And if you'll remember, f of x is equal to x squared begins with a vertex that is at 0, 0, and then goes through the points 1, 1, 2, 4, 3, 9, and then negative 1, 1, negative 2, 4, and negative 3, 9. And it looks a lot like that. So we want to look today at what happens when we take this function and we perform translations on it. So the first one we want to look at is f of x is equal to x squared plus 3. Now, if you think back, I bet you can figure out what this plus 3 on the end of our function is going to do to f of x is equal to x squared. And I think if you think back, you'll remember that anytime we have a number added to the end of a function like this, that this is going to be a vertical translation, and it's going to shift this entire function up 3. So since our vertex initially was at 0, 0, our new vertex is going to be at 0, 1, 2, 3. It shifted our function up 3. So our new vertex is at 0, 3. And if you'll think back to our vertex form of a function, you'll see our h here is equal to 0, and our k here is equal to 3, which gives us our vertex of 0, 3. Everything else about our function is still the same. We're still going up 1 and over 1 for this next point. We're going up to over 2 and up 4 for the next point. And if we wanted to go to the next one, we'd be going over 3 and up 9. So remember, it is still a parabola, so it is symmetrical. It's going to be the same on one side as it is on the other. This one is still going to have the same axis of symmetry at x equals 0, but our entire function has shifted from this point 0, 0 up to this point 0, 3. Now we can also do a vertical translation where we go down. If we have the function f of x is equal to x squared minus 5, then think about what your vertex is going to be here. H is still equal to 0. K is equal to negative 5. So my vertex here is at 0, negative 5. Or we can look at this as a translation. I'm going to translate this function down 1, 2, 3, 4, 5. And I'm going to have a new vertex right here at 0, negative 5. And then my function is going to look just like my first two functions look. I'm going to go up 1 and over 1. I'm going to go over 2 and up 4. I'm going to go over 3 and up 9. And it's going to be exactly the same on both sides of the vertex. So this function, I still got exactly the same shape I had to start with, but I have shifted the entire function down 5. So this is called a vertical translation, and it is moving my function down 5 from the parent function f of x is equal to x squared. Well, what if I want to move it left and right? So let's draw us a new graph over here and very quickly sketch in our parent function with a vertex at 0, 0, and through the points 1, 1, 2, 4, and 3, 9, negative 1, 1, negative 2, 4, and negative 3, 9. And there is my parent function again. So we're going to leave it just like it was and look at what happens when I graph the function f of x is equal to x minus 5 squared. Now, we've talked about translations before in this case, and we noticed that we had a minus h when we talked about our original function here, when we had f of x is equal to a times x minus h squared plus k. We discovered that our vertex on this particular problem is now h is 5, and we didn't move it up or down. Our k is 0, so we have a vertex at 5, 0. So this entire function is going to shift to the right. 1, 2, 3, 4, 5. And I'm going to be right here at the point 5, 0 for my vertex. I'm then going to go through the points 6, 1, because I've gone over 1 and up 1. I'm going to go through the point 7, 4, because I've gone over 2 more. Let's put in some more of our points and graph our function. So the function f of x is equal to x minus 5 squared. Has this general shape. Notice it looks just like our original function. It has simply been shifted to the right 5 spaces. I have gone this direction 5 places. And if I look at any individual point on this graph, if I look at this point 1, 1, notice that it has gone 5 to the right. If I look at this point 2, 4, it has gone 5 to the right. So I can look at any point on my graph, and I have shifted that 5 to the right. I can even come up here and do this one, and I've gone 5 to the right on this particular function. So anytime I have this x minus a number, that's going to move to the right. So what do you think is going to happen if I have the function f of x is equal to x plus 2 squared? You know, think about what it's going to happen to my h value there. My h value there this is minus a minus 2. So this would shift my function to the left. So thinking back, if I've got a value at the end of this function, then that's going to cause me to shift up or down. If that's positive, then I'm going to go up. Positive is always going to make this go up. If I have a negative value, then I'm going to go down. And then if I am inside the parentheses like I am here, x minus a number, this is going to shift to the right. If I have a positive number like I do here in this x plus 2, this is going to shift to the left. These are called translations, and they are the simplest form of a transformation.